Good morning, friends. I hope everyone is doing well. I request everyone to watch my videos in a sequence for better understanding. If you really like my teaching and my efforts, please press the like button, share the videos with your friends, subscribe to my channel, and also press the bell button to get the regular updates. In this video, I want to discuss about the multiplexer, or even sometimes people will call it as a mux also. So I will discuss about the multiplexer and also its combinational circuit and what is the equation. All these things I will discuss in detail. So I request everyone to watch the complete video for better understanding. So first let me define what is a multiplexer. It is a combinational circuit which have many data inputs and single output depending on the select lines. So a multiplexer, you will have many input lines, you will have one output line, and you will have some select lines. So the output will depend on this select lines, that is what they are saying. Now if you have n input lines, you will have log n base to select lines, and you will have only one output line. I hope you are following it. So let me check it. Let me discuss the multiplexer with a small example. So I will take a 4 by 1 multiplexer. Okay, it is a 4 by 1 multiplexer. Why I am calling it as a 4 by 1 multiplexer is this 4 will define how many inputs are there. It is saying 4 inputs. If you have 4 inputs, how many select lines should be there? Log 4 base 2, which is equal to 2. So you should have 2 select lines, which is S0 and S1. Is it clear? And you will have 4 inputs, I0, I1, I2 and I3. You will have only one output line. Now the output, as I said earlier, the output of this multiplexer will depend on the values in the select line. If the select line is having 0 and 0, it will produce the output as I0. If it is 0, 1, it will produce the output as I1. If it is 1, 0, it will produce the output as I2. If it is 1, 1, I think it will produce, not I think, it will produce I3. Is it clear? Are you able to understand? I hope you have understood. If you does not understand, don't worry. I will discuss with the truth table. So you will have S0 and S1 are the two inputs, and you will have the output. Okay, if you have two binary numbers, then how many combinations are possible? 0, 0, 0, 1, 1, 0, 1, 1. 4 combinations you will get. If the select lines are 0, 0, it will produce the output as I0. If it is 0, 1, it will produce the output as I1. If it is 1, 0, it will produce the output as I2. If it is 1, 1, it will produce the output as I3. I hope you have understood the truth table of the multiplexer. Now let me discuss the combinational circuit of the multiplexer. Okay, the same 4 by 1 multiplexer, I will design a combinational circuit. Meaning is that I am designing a 4 by 1 multiplexer. Now we will have S0 and then you have S1. Okay, and you will have S0 and S1, and I0 will be given to an AND gate. I hope it is looking like an AND gate. Similarly, S0, S1 and I1 will be given as an input to the another AND gate. S0, S1 and I2 will be given as a AND gate for, and similarly S0, S1 and I3 will be given as an input to the AND gate. Okay, I hope you are following it. Now tell me one thing. What is the AND gate principle? If all the inputs will be 1, then it will produce the 1 as an output. Am I right or wrong? So now if you see that how it will produce the output. Now if you see that S0 is 0 and 0, then it should produce the output as I0. Similarly, if it is 1 1, then only it will produce the output as 1. Meaning is that then the input for the AND gate should be 1. But now if you see that according to our truth table, if S0 and S1 are 0 0, then only it will produce the output as I0. Am I right or wrong? So what I will do is that I will apply the NOT gate and I will apply the NOT gate. Then I will get the I0. Similarly, when it is 0 1, then only it will produce the I1. So for this AND gate, S0 I will give the NOT, and S1 is already having the value 1, and then it will produce 1, means I1. If it is 1 0, then it will produce the I2. So S0 is 1 and S1 is 0. So I will apply the NOT gate. So both will act as a 1. Are you able to understand why I am applying the NOT? 1 and 0. If I give directly, the AND gate will give the output as 0. So what I am doing, whenever there is a 0, I am applying the NOT gate. Okay. Then I2, you will get it. Similarly, 1 1, I no need to apply the NOT gate. So I will get this one. So I will apply the OR gate. Okay. And I will get the final result. So this value, whether it is I0 or I1 or I2 or I3, depends on these values. Let's take that if S0 and S1 are 1 and 1. Now S0 and S1 you are giving to this one, and I3 you are giving. Is it clear? So this AND gate will be enabled and you will get the I3 as an output. I hope you have understood. Is it clear? Now let me discuss the equation for it. Is it clear? Are you able to understand? So how I am getting it, the final equation? This one I will get S0 complement, S1 complement, and I0, or this is S0 complement, S1, I1, or this one is saying S0, S1 complement, okay, then I2, or this is S0, S1, I3. So this is the equation we generated from this combinational circuit, because we have the AND. So I got S0 complement, S1 complement, and I0. All these things I am given to the OR gate. Is it clear? So I hope you have understood what is a multiplexer, what is the 4x1 multiplexer, and what is its truth table, and what is its combinational circuit, and what is the equation it represents. If you still have any doubts, please ask me in the comment section. I will try to clear your doubts in less than 24 hours. And remember one more important point. Multiplexer can be as a universal gate. How it is means, using the multiplexer we can design the logical gates. How it will be done, I will discuss in the next video. So I request you to watch the next video if you want to know how the multiplexer will act as a universal gate. Thank you for watching this video. Have a nice day.